On page 49, it says politicians, market researchers, and manufacturers, among others, are interested in the true public opinion. Yet in most cases, surveying the entire population is unreasonable. I mean, you just can't do it. Thus, a random sample is used to estimate the true proportion. The margin of error shows the wiggle room on the results of a repeated sample. So the more often you repeat something, the more accurate you will get to what the actual percentage of something might be. Okay? Take a look here up at the front. Now this is actually from last year when we had a lot more election stuff going on. So this was the gubernatorial. So gubernatorial means governor. Governor. It said if the gubernatorial election were held today, who would you vote for? So there was Jennifer McCormick, and at the time she had 39%, and this was a survey or sample that was taken. We had Mike Braun, and we had Donald Rainwater. And do you know who our governor is today? Mike Braun. So Mike Braun did win. It says, notice the margin of error on this particular poll. What is the margin of error? No, that's the number that are undecided. That's not the margin of error. Take a look where you have the big arrow. Yeah, plus or minus 3%. Okay? So plus or minus 3%, what are some possible results within that margin of error? So instead of 39%, what would be the high with a positive 3% margin of error for Jennifer McCormick? 42. And if hers went up to 42 and Mike Braun's went down, then he would have, by 3 percentage points, he would have 39%, right? So if she is increasing and he is decreasing, then basically those numbers are almost switched. So really it's very close race, okay? Now, Donald Rainwater, yeah, he's not very close. But I don't know. Sometimes that's a good thing to have somebody else in there, and sometimes it can be a bad thing because they can take votes away from one of the other two. But then the argument is, do we really want just two parties or do you want three? Do you talk about this in government at all? Are you guys in government at all? Okay. Huh? The branches? I would love to be listening in on that now. Because I better not say. I better not say. No, I better not say. I'm supposed to be not. Well, oh gosh. Let me get started with the problem of what we're doing today. So on page 49, okay, says we're using the M&M prompt, but we don't use M&Ms anymore because a lot of people have peanut allergies. So now we're using Skittles, okay? The manufacturer for Skittles, so you have to change things up in the wording there a little bit, claims that there are equal numbers of each of the colors, and there are 5 colors: red, orange, yellow, green, and purple. Now I have to say, every time I look at these and it's supposed to be purple, I'm like, it's hardly purple. I don't know. It's kind of a, I don't know, purple brown, it seems to me. Anyway, not a blue Skittle? Who knows? And if they ever pass those, color things that say you can't use red dye number or whatever, yeah, then we'll be out of the very pretty colors. Anyway, so the manufacturer claims there are equal numbers of each of the colors: red, orange, yellow, green, and purple. So what percent of each color should we expect? If you have 5 colors, Arturo, put that away. What percentage should we expect if they're all equal? Yeah, 20%, right? Because if they're all equal, 100 divided by 5 gives you 20, so we would expect 20%. So for each of these samples, so you are all going to get a sample. You're going to get a small cupful of Skittles. We need you to calculate the percent of purple Skittles. Okay? All right, and then we'll be answering some questions. Do you think the manufacturer's claim of an equal number of each color in each bag is true? What may lead to this result? What could cause the result to change? All right. So do not eat your Skittles until I say so, until everyone has completed. Now, I would also say, if you want to find out the percentage of purple in your sample, yeah, don't be sneezing here. What else do you have to find? Yes, you have to find the total. Okay, so you have to count them all, and you have to at least count the purples. But if they also make the claim that they are all equal, 49.50, somewhere in there, both of them, you probably should calculate the percentage of all, since they make the claim that they are all equal. Okay? Now, did I count these out? Are they the same number in every sample? No. I just kind of eyeballed it. So don't be looking at somebody else and say, oh, they got so many more. Blah, 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 blah. Don't be saying that. Okay? So go ahead, start calculating. You want to find the percent of purples out of your individual sample. I did not touch the Skittles with the hand. I am touching the Dixie cups or the bathroom cups or whatever you want to call these. Okay? So you can put these on your tissue. That's the idea. Yes? Wow, you got them kind of clustered. Oh, we lost some already. What's the question? Breaking apart, probably. Gently. Now, if you have a half Skittle or something and it's really bizarre looking, I mean, I suppose you can.
So we just separate them.
Yep. You need to separate them and definitely find the percent of purples. You also need to find what else? Total. You need the total to be able to find the percentage of purples, and then I would also calculate what's the percentage of each other type. Because they say, supposedly, it should be equal. Okay? All right, while you're doing that, I will take attendance. Kind of look and try to answer some of the questions that they have in the book, too. But yes, the big thing is, what percent of each color should we expect? We got that. For each sample, calculate the percent of purple Skittles. So I'm going to. All right, so this says, do you think the manufacturer's claim of an equal number of each color in each bag is true? Let's go with that one first. You guys, by the way, if you have your Skittles calculations, you can go ahead and eat some if you would like. Huh? Or you can save them for later, like put them back in the cup and then, kind of crush the top of the cup so it's not all falling out, something like that. So, did anybody have pretty close percents of all of their colors at all? Equal numbers? Or maybe 2 or 3 colors that were close?
I mean, 2 of my colors are the exact same.
And what were those colors?
Yellow and orange. How about that 9?
Close in percents. So, Nehemiah had 9% for orange and yellow.
9% for, yeah, orange.
Anybody else have a couple that were close together, and what were their colors? Yes. Green and purple, 19.1. And were the rest of them lower or higher than that?
One was lower and the rest was higher.
Okay, Jesse, what'd you have?
Red and yellow, both 14%.
Red and yellow were 14%. That was Jesse. Anybody else have a couple that were really pretty close? Yeah. Were what percent? 40? 20. Red and orange, 20%. Oh, so that's kind of right on.
I'm actually kind of surprised a lot of some colors actually are the same.
In the sample you got? I mean, these are all random samples. Do you think anybody got the same percent from one sample to another? Same percentage of colors from, say, Arturo sample to Karan sample? You think they did? Probably not. I mean, all I did was stick the cup in and go, whoosh, there's a cup. Whoosh, there's another cup. Okay? So it was a very scientific way for me to fill these. No, not at all. Huh? Yes, very surgical, very mechanical. So what may lead to this result? So we didn't have an equal number of color in each bag. What may lead to this result? Give me your best educated thoughts on that. Why would they not be all equal? Think about it. If you're the manufacturer, why might these not be all equal? Come on, put on your thinking caps. Why would they not be all equal? Jesse? They probably don't count them. Yeah, but I mean, and I don't know how they actually make Skittles, but I think I've seen on other candy shows, you know, you have the dye in these some kind of containers, and then you put the product in, and it just kind of keeps rolling and rolling in until they're all covered. I mean, why would you put fewer in one and more in another? Wouldn't you put all the same? Come on, guys, think. Why might you have more or fewer of one color of Skittles than another? Say it again. Okay, how you sample them, yes, all right. And maybe if we actually did this and used Kodak, maybe we might be closer than we thought. What are the colors that we're using here? Which are? Where are my art people? People who are in art. No art people. What are your primary colors? Red, blue, and yellow, right? We don't even have blue. How do you make the color orange? You have to mix two to get another one, right? So it takes red and yellow to make orange. So, well, I mean, look at that purple. That is not a true purple at all, right? You cannot tell me that's a true purple.
It's like brown.
I told you, it looks kind of purple brown. So maybe they, okay, so think, what's important when you are a manufacturer? What's really important? What are you all about? Money. So how might that fit in with these colors? Yeah, but how? Well, that's what I'm trying to get you to think about. If they're all about money,
They save money by making their dies.
what is a primary color that is not included here? Blue. But we do have a purplish color, which is made up of red and blue. So maybe, do you see where I'm going with this? If we don't have blue, there must be a reason why we don't have just blue. But we have red and we have orange, which makes red and yellow to get orange. And we have purple, which takes red and a little bit of blue. So what might you be able to claim about the color blue when it comes to making Skittles? The dye. Maybe it's really expensive. Right, they have to mix it. So maybe they use a little bit of blue because maybe the blue is more expensive. Maybe red is really, really cheap because you've got all just red, you've got orange, which is red and yellow, and you've got the purple, which is red with the blue. And then what other one might be a little cheaper? Probably not orange. The yellow, because you have straight yellow, and then you have orange, which takes red plus yellow. And I could be totally off my rocker. I don't know. And sometimes I am. But I don't know. That kind of makes sense to me. I know. Think of all those chemicals. Here we have the naturalist, maybe. Aiden, think of all those chemicals.
Artificial colors, so I think it makes it not.
Well, do you know how you can get natural colors? Do you know? Doesn't orange and red kind of come from, does anybody know this for sure? Don't they come from like taking a certain insect and and grinding it up, and that gives you the color, is it red or orange? They don't do it anymore at all? Oh, so I can't use that. Gotcha. You can use red beets have a very deep purplish red color. Turmeric, that's a spice that gives you that yellow color. Okay. All right. So that's what may lead to this result. What could cause the result to change? So what could cause the result to change? You guys hear what he said? Say that one more time really loudly.
The blue food dyes were toxic in the 70s.
So that's why we don't have blue. But M&M still has a blue.
Yes.
Toxic M&Ms.
They didn't hear about it.
Yeah, back then we were not as interested in that. All right. So how could we get, you all have individual percentages, right? How could we get a more accurate percentage for maybe what was in the bags? How could we get a more accurate percentage of what was in the bag? No. I mean, what did we do the other day when we were doing the 100 rectangles? You weren't here. Yeah, I mean, we took and found everybody's numbers and we were trying to put them together on codouts. So while you are enjoying your Skittles, and if you are not a Skittle person, feel free to share them with someone that is. Okay. Let's just see. Since we have a little bit of extra time, you're like, no. Let's just see what I can do.